In this video, we're going to look at how we can work with indices or powers. Those are those little numbers that sit sort of up in the air on other numbers. So we're going to start off with an example of looking at 3 to the power of 2, or 3 squared, times by 3 to the power of 3, or 3 cubed. 3 to the power of 2 means 3 is written down twice and times together. 3 to the power of 3 means 3 is written down 3 times and times together. And in this sum, we're timesing those two bits together. So we've got 3 written down 5 times and times together. So that could be written as 3 to the power of 5. Now what you can actually do with these, you can just spot that these powers here, these indices, just get added together. So the 2 and the 3 added together to give us the 5. So if you're multiplying and the big numbers here are the same as each other, and that's important, these big numbers have to be the same as each other. If you're multiplying, you can just add the powers together. So if you have a look at another example, if you have a look at 7 to the power of 5 times by 7 to the power of 6, because the big numbers are the same as each other and we're timesing, that's the same as 7, the big number stays the same, to the power, well, 5 add 6 is 11. So that would be the same as 7 to the power of 11. We can use these rules when we're dividing as well. If we had 5 to the power of 8 divided by 5 to the power of 6, you won't be surprised the answer's got a big 5 in it as well. But when we were timesing, we added the powers. If you're dividing, you do a taking away with the powers. And 8 take away 6 is 2. So that one would be the same as 5 to the power of 2. If you're dividing, you do a taking away with the powers. Let's look at another one. If we had 3 to the power of 4 divided by 3 to the power of 5, the answer will have a big 3 because these numbers are the same, they're both 3's. And if we're dividing, we can do a taking away. So I'm going to do 4 take away 5, and I'll just write that working out down. 4 take away 5. Now 4 take away 5 is going to take you into negative numbers because you can't take 5 away from 4, there isn't enough there. 4 take away 5 is minus 1. So you can get answers where there are minus powers. It's also worth me mentioning at this point, 3 to the power of minus 1, any number to the power of minus 1 is the same as 1 over that number. So 3 to the power of minus 1 is the same as 1 over 3, or 1/3. If I got 7 to the power of minus 1 from another question, that would be the same as 1 over 7. Moving on, you can have other questions which give you minus powers as well. If we look at 4 to the power of 4 divided by 4 to the power of 7, we've got to do a taking away because we're dividing. 4 take away 7 is minus 3. So I would have 4 to the power of minus 3. The minus power means 1 over, just like it did here. But it's not just 1 over 4, because that would be 4 to the minus 1. If there's a 3 here, that's got to come down here as well. So 4 to the minus 3 means 1 over 4 to the power of 3. Remember, 4 to the power of 3 means 4 times 4 times 4. And if you worked out 4 times 4 times 4, 4 fours is 16, times that by 4 you get 64. So that is actually the same as 1 over 64. If we look at another one, 7 squared times by 7 cubed over 7 to the power of 4. Remember, an over like this means a divide. Well, let's do the top first. On the top of the fraction, which is the numerator of the fraction, we're timesing. So we can add the little numbers, add the powers together. 2 plus 3 is 5. So that's the same as 7 to the power of 5. And on the bottom, I've got 7 to the power of 4. Now I said that an over, like this, a line here where something's over something, means a divide. So that question is exactly the same as 7 to the power of 5 divided by 7 to the power of 4. Because we're dividing, we can do a taking away. 5 take away 4 is 1. That's 7 to the power of 1. And it's worth remembering that anything to the power of 1 is just a number itself. So 7 to the power of 1 is just 7. If I'd had another question and that had given me an answer of 12 to the power of 1, that would just be the same as 12. Now we can use these laws of indices, as they're called, in algebra as well as with numbers. If I had x squared times by x cubed, now it's really quite important now that you make your x's and your times signs look different. That's one reason why we use these curvy x's. Because I'm timesing, and these are the same thing here, they're both x's, I'll have that x in my answer. And 2 add 3 is 5. So for that one I'd have, that's the same as x to the power of 5. If I had another example, 2x squared times by 4x cubed. Here I've got a mixture of big numbers, the 2 and the 4, and powers, the 2 and the 3. You deal with the big numbers, the normal numbers first. 2 times 4 is 8. So effectively now that 2 and that 4 have gone, and you're left with an x squared times by an x cubed. So that'll be an x, and when you add their powers, just like in the last question, you'll have x to the power of 5. So the final answer there will be 8x to the power of 5. If you have a look at another one like that, 3y to the power of 7 times by 4y to the power of 3. Deal the big numbers first. 3 times by 4 equals 12. And then you can use the laws of indices on the y's. Y to the power of 7 times by y to the power of 3. Because we're timesing, we can add the powers and we'll get y to the power of 10. We can do this with dividing as well. If we had a to the power of 7 divided by a to the power of 4, because that's what this means here, if you've got an over, that's a divide. That's just the same as a to the power of 7 divided by a to the power of 4. Remember, when you're dividing, you do a taking away, so that would be the same as a to the power of 3. If we look at some other examples, if I'd had y to the power of 5 over y to the power of 8, that over means I'm dividing, so I could write it down as y to the power of 5 divided by y to the power of 8. If I'm dividing, I can do a taking away. 5 take away 8 is minus 3. So you can get these minus powers coming up in the algebra examples as well. And the minus power just means 1 over what we had here without the minus sign. So if I took the minus sign out, I'd have y cubed. So y to the minus 3 is the same as 1 over y cubed. If we look at just two more examples probably, 3x to the power of 7 times by 4x to the power of 6 over 6x squared. Make sure we can see that one. Let's deal with the top first and we'll leave the bottom alone. We'll deal with that one in a minute. 3 times by 4 is 12. X to the power of 7 times x to the power of 6. If we add those powers, will give me x to the power of 13. Now the question I've got is the same as x to the power of 13 divided by 6x squared. Deal with the normal numbers first, the big numbers. 12 divided by 6 is 2. X to the power of 13 divided by x to the power of 2. If I'm dividing, I do a taking away with the powers, so I'll get 2x to the power of 11. And the final one for now, if you had a cubed, which was then all squared, that means a cubed times by itself, a cubed times by a cubed. And if you're timesing, you add the powers. Now you can miss that middle step out. A power to a power, you can just multiply those powers together. 3 times by 2 is 6. You can go straight to that. So if you had x to the 7 to the power of 4, you could say that's the same as x to the power of 28.